I want to say hello, everyone. Welcome to webinar 4 out of 6 in the Community Science Long Island webinar series. My name is Sally Kellogg from the South Shore Estuary Reserve Office, and I will be moderating today's Eelgrass webinar. The goal of Community Science Long Island series is to highlight various community science opportunities around Long Island and how the data accumulated by the public influences local environmental management efforts. The Community Science webinar series is brought to you by South Shore Estuary Reserve, CTUC, Long Island Sound Study, New York Sea Grant, and the Peconic Estuary Partnership. A few housekeeping notes. This webinar is being recorded, and the recording will be available on CTUC's website shortly after the webinar concludes. Your video and microphones are turned off, but you are free to ask questions in the Q&A section at the bottom of your screen. If you don't have a question but want to share a resource or discuss amongst the group, you are more than welcome to use the chat box. Tonight's webinar will cover eelgrass, which is a type of underwater marine plant found throughout the Northeast Atlantic coast. Eelgrass beds provide direct benefits in the form of nutrient cycling, wave energy reduction, carbon sequestration, and provide habitat for important species including seahorses and bay scallops. These benefits support commercial fisheries, tourism, atmospheric carbon reduction, and coastal resilience on Long Island. For these many reasons, the conservation and restoration of eelgrass is an important effort being undertaken by Cornell Cooperative Extension of Suffolk County's Marine Program. Our speakers tonight include Stephen Schott, who has a bachelor's in botany and master's in biology, specializing in marine botany and ecology from the University of Rhode Island. He has been employed by Cornell Cooperative Extension since 2000, working with the Habitat Restoration Program. His work focuses primarily on shoreline, tidal wetland, and eelgrass restoration and monitoring. Kim Manzo, who has worked for the Habitat Program at Cornell Cooperative Extension Marine Program for 18 years, is our other speaker. And her work focuses on the restoration, monitoring, and public awareness of our marine habitats on Long Island. She is an experienced scuba diver, as well as lead educator on habitat-related programming out of Cornell Cooperative Extension Southold and Hampton Bays facilities, and conducts outreach education, including hosting public marine meadows workshops and seahorse conservation work groups and lectures. So, without further ado, I would like our presenters to begin. Steve.
All right, let me set this up. Everyone can see my opening screen?
Yes.
Okay. Good evening, ladies and gentlemen. Tonight, Kim Manzo and myself will be discussing some of our work and around eelgrass, which is a seagrass found in all of our estuaries in New York and Long Island. Basically, we're going to be discussing why eelgrass is important and what can be done to save them, because they are imperiled, not just in New York and Long Island waters, but throughout around the world. So I'm going to take half of the discussion and give you some of the background and the biology, ecology, life history, and importance. And then Kim is going to discuss opportunities that we provide the community to become involved in the work that we do to help restore and protect eelgrass. So what are seagrasses? So on Long Island, we have a lot of plants that grow around the water, and we get a lot of confusion in when we have people come to us to ask us questions. Not all the grasses you see are actual seagrasses. So seagrasses are higher plants. They're related to grasses that you normally would think, but they are not actual grasses. Like higher plants, they do use pollination to produce seeds, and all of this is done while entirely living underwater. Like plants, land plants, they have roots and rhizomes, or in this case, rhizomes being underground stems. Think of this rhizome and root situation like irises that you would have growing in your gardens at home. They're found in seagrasses in general are found in waters that are brackish, anywhere from the low teens all the way into open ocean waters that have salinities greater than 30 parts per thousand. And currently, and this fluctuates back and forth, there are about 72 species of seagrass found worldwide. We have one true species of seagrass on Long Island, Zostera marina, also known as eelgrass, which I'll be focusing on. And then we have one other grass that some consider a seagrass, others don't, and it's widgeon grass, which is Rupia marittima. Pretty common to find that on the South Shore, in the South Shore waters, as well as parts of the Peconics. So what is not seagrasses or eelgrass? In this case, it's over here, not any of the seaweeds. How can you tell the difference? Seaweeds do not have roots and rhizomes. Typically, if they're growing in places that don't have access to hard substrates like rock or a lot of shell, they're just drifting and floating on the bottom. In places where they have hard substrate, think Long Island Sound, Eastern Peconic Estuary, or even on growing on bulkheads. If it's growing attached to that hard substrate, it's most likely seaweed. The other commonly confused organism or plant that we have people telling us that, oh, why do you guys do eelgrass restoration? I've got acres of it behind my house on the creek, and they're referring to salt marsh grasses. While these do grow in the sea, they grow intertidally. So part of the tide cycle, at low tide, they're exposed and growing out of the water, and at high tide, they're growing partially submerged. They are not seagrasses. Eelgrass grows its entire life cycle underwater. So just to give you an idea of how seagrasses came about, they're a relatively new step in plant evolution. We started out early on with single cell plankton, single cell algae. Over millions of years, some of those single cells conglomerated into multicellular organisms, and you have your red, green, and brown algae. Overachieving green alga decided to make the leap onto land and spawned the evolution of land plants as we know it, your trees, your grasses, your terrestrial grasses, ferns, and the like. All of those plants came about from the ocean. Now, some of these plants were not happy with their time on land. Some just wanted to get back to where they came from. So you had a continued evolutionary change with plants like mangroves, where they grow rooted in salt water, but they're not growing totally submerged. And then you had the seagrasses evolved, which are relatively new in evolutionary times, where these plants move their entire life history under the water surface. So this is not an old plant. This is actually a new plant, and very, very interesting life histories and evolutionary paths that they took to get here. So for eelgrass, our local species of seagrass, Zostera marina, it is a northern hemisphere temperate water plant, which that means it likes the colder waters. It will not grow into the tropics. These are the current distributions, these green lines along the coast. These are all the same species. So the species that grows in the Great South Bay, the Peconics, and Long Island Sound is also found in the Aleutian Islands, Japan, and all the way up into northern Scandinavia, almost to the Arctic Circle. They are most likely different genetically, just because of the isolation, but they all share very common traits, and they, for the most part, act the same in all of these different locations. One of the things that is occurring currently is with global climate change and warming of waters, these southern limits are moving north. So eelgrass, as waters warm, and especially summer water temperatures exceed their natural tolerances, those populations are dying off in these southern ranges, and the population is basically migrating to the north. So this is a close-up of what an eelgrass plant would look like if you were to go out in Great South Bay and carefully dig it up out of the bottom. They typically grow in nice soft bottoms, in this case nice and sandy. Makes it very easy for them to expand their rhizomes and anchor. So just some of the terminology to quickly go through, because I use it and I don't want anyone to be confused. So we have the stem of the plant. A rhizome is an underground stem, and from that arises roots at sections on the rhizome called nodes, and as well as blades, which hold the leaves. The meristem, or the growing part, constant growing part of the plant, is always at the end, and so this plant is always growing to away from all of this older growth. So the newest growth is always heading away this way. And at given intervals, the plant will put up new shoot with new blades and new roots. At the end of the season, this coming up soon, probably October, the plant stops growing for a little bit, and this meristem creates a flower shoot or a flower bud, and also splits off with two vegetative branches. So it kind of forks off, and in the middle will be where the flower that produces the seeds will grow in the spring. This diagram is really important for people who are interested in, in the life cycle of eelgrass. The really cool thing about this is that back in 1929, Dr. Seschel, who was working with eelgrass populations in Southern California, discovered that really the plant's life cycle is dominated by two temperature points. And in that cycle, when the plant either comes up into those temperatures or goes back down through them, a key part of its life cycle takes place. So we'll start over the winter. Eelgrass does grow in temperate regions. We have it all the way up into the Gulf of St. Lawrence. It grows around Greenland, so it can tolerate pretty cold temperatures. Locally, our eelgrass doesn't die back, and it doesn't really enter what people would normally consider dormancy. It's still growing, it's just slow. And a lot of the reason for it to be slow and not dormant is, with any organism, if you get colds, your metabolism slows down. So if we have warm winters, we may see more growth in the eelgrass. The interesting thing is we have germination of seeds here as the water temperature drops through 10 degrees or 50 degrees Fahrenheit. The seedlings grow at a pretty good rate all winter. So by the following June, so they germinate sometime in November, December. Some will continue to germinate all through the winter, but by June, they almost look like adult plants. So they put on pretty phenomenal growth. As the water temperature comes up in early spring through 50 degrees, the flower shoot of the plants starts to really grow. By mid-May, you could tell the difference. Flower shoots look different than the regular vegetative shoots that we see throughout the rest of the year. If you were to look at them at this point, they're really starting to look different. And typically in our area, I know Stony Brook starts to do their seed collections in the South Shore, probably around the 20th of June. And anywhere, it depends on temperature, again, on how fast the seeds develop. That could go into early July for the South Shore estuary. The Peconics, we usually start the second week to the third week of July, and then into Long Island Sound, we could collect seeds into August, especially out by places like Fisher's Island. So seeds are released during those periods of time. Typically in the summertime, because eelgrass does not like high water temperatures, anything over 25 degrees or about 74-ish, they start to get stressed. Anything into the low 80s, over 80 degrees, you could actually cause dieback and sloughing of leaves. So they'll basically just drop their leaves because of stress. This is something that commonly happens in the Chesapeake during the summer, where eelgrass actually just releases its leaves for July, August, and September, and basically lives off its reserves in its rhizomes, and then it pops leaves back out in October and all the way back through into June. We don't have that happening here yet, but with climate change, that might be something that we see happening more and more, especially in the South Shore estuary or some of the warmer meadows in the Peconics. And again, in the fall, we have the water temperatures dropping down again, and the seeds will start to germinate in November. So that's our cycle. It's very important for people who work with seagrasses, because this gives us our timing of when we want to be doing restoration, when we want to be doing monitoring to get the most out of things. So why is eelgrass, or seagrasses in general, important? They provide a lot of what we call ecosystem services, and those are services and processes where they produce some kind of resource for the environment that are useful either just for the environment or for us as well, that we and produce an economic value. Some of the services and most important services that eelgrass provides for us, especially on Long Island, the number one thing we think about is habitat value. And one of the key critters that live in eelgrass that people love to think about are scallops. So the bay scallop had evolved over time and has a life history that's tied pretty tightly to seagrass meadows. It uses them as a refuge from predators. Little bug scallops are able to attach themselves up off the bottom on eelgrass blades that predators like crabs cannot climb up and get them. And they stay in those refugia until their shells are thick enough and they're large enough that the crabs are no longer a threat. Other species of fish, their juvenile stages, will use eelgrass as a refuge from predators as well. If you think about most of Great South Bay, the Peconics, most of it is these open, shallow, sandy bottoms. There's not much structure, and unless you're a flatfish like a flounder that can bury itself, it's very difficult as a juvenile to hide from a predator. Once you throw in this three-dimensional structure of an eelgrass meadow, it's almost like acting like a forest. It gives you places to hide, nooks and crannies, a lot of surface area, and that's a very good thing for all sorts of animals. Additionally, and this is something that's tied in with some of the shoreline work that we do at Cornell, offshore eelgrass meadows actually help protect the shoreline during storm events. They provide erosion control by knocking down waves. Research has found that eelgrass meadows can decrease wave heights and wave strengths by up to 20%, possibly even more, depending on the density of the eelgrass meadow and how large it is, and the distance the waves have to travel over it. That prevents less damage on shorelines during storm events, because those waves are storm-driven waves are not hitting with as much force. They also, as those waves do crash onto shore and start to drag our sediments and sand away, eelgrass acts kind of like a snow fence offshore and prevents those sediments from being dragged and washed too far offshore where they can't be reincorporated naturally back into the shoreline. So there are examples on the South Shore estuary along the North Shore Fire Island where sections of shoreline, if you look at aerials on Google Earth, you could see it generally is light colored sand offshore, and you'll see the dark areas where there's seagrass. The areas of shoreline that seem to have the most erosion are those that don't have seagrass meadows offshore and adjacent to them. The waves basically in north winds during the winter have no, they're not checked at all as they come in, whereas the areas that have offshore eelgrass meadows seem to have less. We have things like sequestration, which Sally mentioned, carbon, nitrogen, and phosphorus. All of these are important for improving water quality and also for global climate change. And then just the biodiversity that's found within these meadows. So the current status of eelgrass on Long Island, basically, if you were to take a time, go back in time and hit back before 1930, pretty much every creek, cove, harbor, bay on Long Island had eelgrass on the bottom. And in most cases, it was considered a nuisance. It fouled boat props, it washed up on beaches and made a mess. That's not, unfortunately, the case anymore. Over the last century, we've lost upwards of 90% of all the eelgrass meadows on Long Island. And we've lost all of the eelgrass meadows around New York City. Jamaica Bay, there's sections of Jamaica Bay that used to be entirely eelgrass meadows. One's called Grassy Bay for that reason. So we've suffered a lot of loss with eelgrass, and really, if we continue to go as we're going, and this is a global problem, we're losing eelgrass or seagrasses worldwide at a rate of almost 2% a year. And it's estimated we've lost over 30% of all the eelgrass that we once had in the world, seagrass in the world. So we need to do something to at least curb this, or to try to reverse this process, or else we'll wind up like the New York City area, and we'll have no eelgrass at all. And one of the things we can do is work with restoration projects and try to form founder colonies, and also kind of fortify existing eelgrass meadows so that they survive and can hopefully regenerate naturally. So what caused eelgrass to disappear? This started back in 1930 with a wasting disease epidemic, which killed off 90% of the eelgrass in the Atlantic. This is a cellulose slime mold. It still exists, but the eelgrass that survived the epidemic in the 1930s was resistant to this slime mold. Those are the eelgrass genotypes or types that are existing today. They still do, if they're stressed enough, high water temperature, changes in salinity, or other issues that could stress them, will succumb to wasting disease. We still see it regularly in the populations, but for the most part, it's kind of like us with the common cold. It's out there all the time. Usually it's a nuisance, and it doesn't kill us, but given the right circumstances, it could be lethal. A lot of eelgrass before 1980 was lost due to navigational dredging. All the shallow areas in the creeks, the coves, and the harbors where eelgrass was, those are the areas that we wanted to deepen so that we can get bigger and bigger boats in there. So basically the eelgrass was dug up, thrown on the beach, and it died. And then the depths in those areas were made to be too deep for eelgrass to get enough light. Then we get into the 80s, we have brown tide and other harmful algal blooms, which still persist. As everyone knows, Long Island has continued to develop, which has led to reduced water quality, increasing in number of boats on the water, and other human activities that impact eelgrass. And then global climate change. Eelgrass is very susceptible to increasing water temperatures, and that's really what's gotten us to the point we are today. So this is my last slide and what we can do. So things that we need to do: improve water quality, which we've been working on. This would alleviate algae blooms, increase light availability for eelgrass, avoid direct impacts to eelgrass meadows. That includes any kind of construction and such. Be more responsible with how we develop our coastlines, as well as handling our boats and shellfishing. Support actions that address environment and climate change. And leading into the next section of the talk, volunteer for eelgrass restoration projects. And with that, I will pass on to Kim.
All right. Hello. I'm here. All right. Hey guys. All right, so I'm just going to jump right in and start talking about our Marine Meadows program, kind of how it evolved, now that you have some of that background information from Steve. Yeah, so I'm going to start. So just these are kind of the things I'm going to go over today. You know, just the things we think about when we're restoring eelgrass, the basics that we've learned over the years, how the new method has evolved, details of exactly how we plant using this new method, the establishment of the Marine Meadows, citizen science program, And then just what it's like to come to a workshop and some of our current partners and restoration sites. And I'll finish off with ways that you guys can get involved this year. I'm actually going to start off right now by playing this little 2-minute video. Okay. All right, so I just want to kind of go over more detail and everything that was kind of summed up in that video. So the things that we think about as we're looking at a new restoration site, of course, site selection is extremely important. Sorry about that. You guys hear me?
You bounced out for a second, but you're back now.
I lost my, I can't see my software anywhere. So I'm just hoping that everyone can see everything. Okay. All right, let's see. All right, so of course, site selection is extremely important. We want that site to have great water quality, clear water, make sure the temperature is cool enough throughout that summer stressful time like Steve was talking about. So a lot of times when we're looking at a new area to try to restore eelgrass, we'll start off by putting out light loggers and temperature loggers and try to get about a year's worth of data to learn a little bit about the physical, parameters at that location to see if it's even worth doing a test planting there. Of course, whenever we do a restoration project, we want to start off with healthy stock, nice healthy eelgrass that we collect. Also, we like to try to collect it from an area close to where the planting location is going to be, so that it is hopefully sort of adapted to those conditions in that water body. Also similar, depths, temperature ranges that it is being collected from, so that hopefully that helps to, make it easier for that whole acclimation process. Of course, we have to figure out how we're going to anchor the plants down into the bottom, because often, when we go to plant eelgrass, a storm could come right through within a few days, and it's very vulnerable to just being uprooted and washed away. So we've learned over the years that we need to anchor these plants down in one way or another, depending on what the sediment is like at the restoration site. So other considerations, of course, would be, we want to make sure it's inexpensive and not too labor intensive. Of course, we want to try to avoid things that are susceptible to bioturbation or erosion. I'll kind of talk about that when I talk about some of our older methods. And then also ideally that we don't have to come back to and remove anything from, that once we plant it, we are finished with that planting process and we just have to come back to check on the grass itself. All right, so in terms of eelgrass restoration, of course, there's basically two mentalities. There's restoration via seed, or there's restoration via using vegetative shoots of eelgrass. So for the seed restoration, we used to mostly do broadcast seeding. This involves us going around, as Steve had mentioned, with how eelgrass is a flowering plant. The flower shoots, they're usually developed sometime between June and August, depending on what water body we're talking about. June is usually, down in the South Shore bays, and then August, usually up in Long Island Sound, where the water is a little cooler. So we would go collect lots of these flower shoots just before the seeds are about to, fall out naturally. We bring those back to our greenhouse with flowing seawater tanks. We process them out and we collect the seeds. So that's one way we could just broadcast them into a restoration site. But we also developed this method called buoy deployed seeding. This was done back when we were trying to figure out a way that, other citizen science organizations could get involved in eelgrass restoration without having, say, a greenhouse or some type of facility that they could bring these plants back to. So the idea with buoy deployed seeding is that we can collect the eelgrass flower shoots, put them directly into these nets right at the restoration site, the same day that they were collected, potentially. And they naturally finish developing and raining the seeds out. The seeds are negatively buoyant, so they fall out, sink to the bottom. And we often would do like a large grid area of these buoy deployed seeding setups. So for eelgrass restoration using vegetative shoots, we used to use this method called the turfs method, developed up in New Hampshire by Fred Schott. So basically it was these frames of lobster pot material that we would actually use tissue paper and tie the eelgrass to the bottom of these frames and then place the frames on the bottom. And after a few weeks, you would come back and remove the frames. So that's why in that previous slide, I mentioned how we try to avoid now using things like this, that we have to go back and pull these frames back out. Of course, this was a huge limiting factor in terms of how many frames you had available, how many you could fit on your boat at a time to, for deploying and for retrieval. And of course, I mentioned bioturbation. These frames tended to be very attractive to crabs. And unfortunately, crabs can be a problem for us in the summer months. When the water is warm, they get very active and they can dig up a lot of our eelgrass. So we don't want to attract any more crabs. So then we also used to do this method called free planting, which was literally taking a shoot of eelgrass and pushing it into the bottom with your finger. This picture you see here shows, I believe that's Steve, but these were 1 meter diameter planting rings that we used to keep track of about how many square meters we were planting. And the thing about this was it was very susceptible to storms, as I had mentioned, that all it took was bad weather within a week or two of us doing the planting, and all that work was pretty much for nothing. So we needed to start coming up with ways of anchoring the plants. So after that, and we started doing a lot more work in Long Island Sound. This was back in about 2010 or so. We discovered a new method called rock planting. Now, of course, in order to do a rock planting, you need to have a rocky bottom. This is a method that's obviously better suited for Long Island Sound. It's still a method we use today for a lot of our sites in Long Island Sound. So how was the burlap method developed? So I was just speaking about that rock planting method. So we just decided that there were these sites in Long Island Sound in some areas that were large sand flats, and where we didn't have rocks, we wanted to make our own rocks and try to anchor the chutes down that way. So we started out by actually making sandbag rocks out of like burlap bags. And it turned out, it worked to an extent, but it actually did end up causing a lot more problems with erosion. It was very labor intensive making all of these artificial rocks, as we called them. So little by little, we started just kind of burying the plantings, and then we realized we really didn't even need this artificial rock at all. So we developed this brand new method known as the biodegradable disc method. We also lovingly call it the tortilla method. That's because it kind of looks like a tortilla. Okay, so just to go through the process a bit. So for this new method, and for basically any eelgrass restoration work that we do, we start off by sustainably harvesting eelgrass from natural meadows. Now, some people wonder, why can't we grow our own eelgrass from seed? That has been done. Unfortunately, eelgrass, as Steve mentioned, and we've talked about with climate change and everything, eelgrass is a cold water plant. It doesn't really do well in aquarium settings, so it could be very challenging to have enough of a chilling system to really get it to that optimal temperature that eelgrass likes to grow. So we have found that we're better off sustainably collecting from natural meadows. This way we can make sure that the plants are used to being out in the natural environment, not in a tank setting. Also, we try to collect, as I mentioned, from sites that are nearby to where the restoration site's going to be. So hopefully they're somewhat adapted to those types of conditions. All right, so sewing a burlap disc. So this is sort of the how-to with our new method. Basically, you take a piece of eelgrass and holding it from the bottom along the rhizome, you sort of weave it through the two holes. So the one outer hole and then the hole that's just inside of it. So as you can see here, that's kind of a close-up of what it looks like for each shoot going through the two holes. So each disc holds 10 shoots of eelgrass. So this is what a completed tortilla looks like on the right side here. The top left picture shows a bunch of tortillas freshly made after one of our eelgrass workshops. And then the bottom left picture shows those tortillas that are ready to get planted. Those are on the skewers that the divers bring down with them. All right, so just a little more detail on the tortilla method. So a single planting unit, as we would call it, would be one single tortilla with 10 shoots. Often we'll do smaller test plots just to sort of test whether the conditions are okay for the eelgrass there. And then we'll sort of scale it up from there. When test plots seem to be doing well, we scale up to smaller patches of around 50 to sometimes about 100. And then from then on, we'll do several hundred in a long-term restoration site. So the tortilla method, these are the components that you basically need. At the top, you see that skewer that I mentioned. So we just use a little, I think it's a 2-pound little clip weight. And we bring down about 50 tortillas on each of those skewers. So as a diver, sometimes we have 1 skewer, 2 skewers, depending on how many tortillas we have to plant that day. Other important tools, you see that, that ring, it's just a piece of PVC cut into these rings that we basically use as like cookie cutters, I like to say, that we push into the bottom. Then we use that fancy shovel there, also known as a clamshell, to scoop the sand out, bring that level of sand down, and then we place the completed tortilla into the that spot and put the sand back on. So you can kind of see here, this is one of our divers scooping the sand out and bringing that level down. And that's when they would go down and place the finished tortilla into and put the sand back on and then pull the ring out. Yeah, so actually there it is right there. So as I mentioned, you know, you're pushing in that PVC ring, you're scooping the sand out, leveling it so that it's all, you know, nice and flat at the bottom. You're placing in the completed tortilla, scooping the sand back on, and you're pulling the ring off, and voila, you have 10 shoots of eelgrass planted. And just the weight of that sediment on top of that burlap disc is enough to anchor that whole tortilla in place long enough, ideally, that the roots start to take hold. And after 2 or 3 weeks, that burlap isn't really as necessary anymore. It's more that the roots are starting to take hold, and that's keeping it in place at that point. So after planting, this is just showing some pictures when we come back to monitor the following spring or summer after we do an eelgrass planting. Often we'll see a lot of growth. You know, the shoots, if they're happy, they'll start putting out, you know, cloning themselves, putting out laterals and, you know, doubling, tripling in number. So it's exciting to see, you know, when a site is successful, how quickly they do actually grow. So advantages of this method. Of course, it's reducing the amount of bottom time for us as scuba divers, especially when we used to plant 1 shoot at a time. Now we're planting 10 shoots at a time. It's also increased the scale of the plantings that we can do and the number of plantings per year that we could do. So obviously it's made us a lot more efficient. Of course, less time in the water when the water is nice and cool, when the eelgrass is happy, but the scuba divers are a little less happy. This makes us, you know, obviously not have to extend our dive season into those winter months. And of course, since so much of the work is done above water, this opened up a whole new opportunity for us to have, you know, a citizen science program evolve out of this method. So that's how the Marine Meadows method, Marine Meadows program was born. So when we have a Marine Meadows workshop, we will often have it either at our facility. We've had restaurants host for us, other environmental organizations, and we've worked with all of East End towns, a lot of parks and preserves and beaches. We've worked with, you know, scout groups and things like that. So we're open to all different types of hosting locations for these workshops. And really, we can set up anywhere, and it was pretty COVID friendly. Even during COVID, we were able to still host workshops because it was all outdoors. We could space people out 6 feet or more apart from each other, and still, you know, get this work done and get people participating. So these are just some pictures from some of our recent workshops. So basically, when we have one of these Marine Meadows workshops, we start off by, you know, introducing ourselves, kind of explaining, you know, what we do. We have some informational signs that we go over, you know, a lot of the stuff we're talking about today, but kind of like the, you know, the shorter version about why eelgrass is so important, how, you know, we're losing it at a rapid rate, and all these things that we can all do to help. And then we just get busy with weaving our tortillas. So just to kind of go over the timeline here, we talked about how the shoots are collected from natural meadows. We host a workshop. Then after the workshop, we have our planting. So we try to schedule, planting the tortillas as soon as we possibly can. Of course, the fall tends to be challenging in terms of, the wind and the weather. So we get out on the next possible nice day that we can get out to plant after a workshop. And then we also just follow up with monitoring the following spring or summer to see how those plantings did. So I just wanted to show this slide because it shows that really an integral part of our whole program here is that we have the ability to hold shoots. We have flowing seawater tanks at Cornell at our facility in Southold. So when we go to collect eelgrass, in the top left picture, you see that those are collected eelgrass shoots getting ready for our workshop. So the week prior to a workshop, we go out and collect the eelgrass. We have to make sure we keep it very happy and cool and, not let it get stressed prior to the workshop. Then it all gets packaged into coolers and brought to the hosting location. And then, of course, on the bottom right over here, after a workshop, as I mentioned, we often have to wait until the next, nice weather day to get out to plant these. So we are able to hold them in those same seawater tanks back at our Southold facility. These here, we usually put them in stacks of 5. So we keep track of how many tortillas we have to plant. And then in that bottom left picture, that's the one that's, they're ready to get planted. That's for planting day. They get put onto those skewers and brought right down to the bottom of the divers. So in the off season, we mentioned, of course, the fall is really our primary time that we do these eelgrass workshops. That's the ideal time of year for planting eelgrass. But there's a lot of other work that we can do for the rest of the year when the temperatures aren't ideal for planting. And that's, of course, making all of these burlap discs. So we've had a lot of different groups volunteer for us to make these discs. We actually had, I believe it was the Hampton Bays shop class make our original, we call them presses. So you see on the top, in the top right picture over here, you see these wooden things with these spikes popping out. And that's actually how we make these burlap discs. So we just kind of press the burlap in between and cut around it. And yeah, so that's a fun thing that even some of the younger generation can get involved in with helping with the eelgrass restoration. Okay, and so yeah, I'm just about done here. So this is how we sort of promote our workshops. We make flyers, we promote on social media. And we have a lot of different, informational handouts, just trying to teach people about the importance of eelgrass. We have a lot of different sort of spin-off programs. Like I have the Seahorse Conservation Initiative now, which is basically just a fancy way of getting people in the water, looking for seahorses, but at the same time, getting a chance to see all the other animals that utilize eelgrass, and so they can have some appreciation for it. Yeah, and just, I think this is pretty much lastly, we've also kind of expanded the Marine Meadows program to not only be these eelgrass weaving workshops, we're also now having workshops for planting coastal plants and other, so up top we have a Spartina planting, we also do beach grass plantings, and we even this year started, we did a workshop with buoy deployed seeding. We had people meet us down at Tiana Bayside and help us to stuff our eelgrass nets with the flower shoots. So there's a lot more potential with this program to work on all different aspects of marine habitat restoration. Oh, I had this real quick. So this is just, it just shows all the different sites that we have, past and present. This is only really a glimpse of what we've had going on over probably the past 10 years or so. There were a lot more prior to that. But just, if you just kind of focus on those little yellow arrows there, those are our current restoration sites. And I'm just going to cruise right through because I'm getting low on time. And so this fall, I'm announcing that we have 2 public workshops that you can get involved in. We have one scheduled for October 15th at Cutchogue New Suffolk Library. We have one scheduled for Saturday, October 29th at the Bellport Village Marina. And yeah, if you use the QR codes there, you could scan them to get to the registration page. Otherwise, you could just go to marinemeadows.org, and right on the homepage there, they link directly to the registration sites. So that's it.
Awesome. Thanks, Kim. It looks like we don't have any comments or questions at the moment. So if folks have any questions for our presenters, for Kim or Steve, I would encourage you to pop it, to just type that in now. I guess I would start off with a question. Where do you guys find the biggest meadows? Where are most of the meadows found currently around Long Island?
The South Shore Estuary Reserve has the most. I believe based on the 2018 aerial survey, you had over 10,000 acres. The Peconics has under 900 acres based on the last survey done in 2014. And then Long Island Sound is looking in the 2,000 plus range, I believe. So yeah, the South Shore Estuary is phenomenal. However, in 2002, the South Shore Estuary had over almost 20,000 acres. So in 16 years, we lost about 45 to 50% of the meadow, and a lot of that has to do with HABs. So all the algae bloom issues we have down in the SSER. But yeah, the largest meadows by far, and in the SSER, most of those meadows are in Great South Bay, so they're concentrated in the western part of the estuary. So,
at what depths? We have a question. At what depth? What's the depth that they need to be planted? The tortillas need to be planted.
You could take that, Kim.
Yeah. So I'm guessing depth within the sediment is what we mean by that. We usually go down 1 to 2 inches, depending on the sediment type of that area. We don't want to go too much deeper than that, but as long as we don't completely bury the sheath area of the eelgrass, we have a little wiggle room with how many inches to plant it. So it's really sort of the deeper, the better. The deepest we can plant it, the better.
Julia meant water depth.
Oh, okay. So that's why I wasn't sure.
She followed up. I just saw it pop up.
Okay. Water depth completely depends on where. So the South Shore Estuary Reserve is very shallow. The eelgrass grows naturally. At low tide, you can find it in 1 to 2 feet of water. But then you go out to Long Island Sound around Fisher's Island, and it's growing in 20 feet of water in some areas, or even more. So it all very much depends. We like to, we've already sort of done our homework at that point that we're starting the planting process. So we sort of go by, what the eelgrass in that area, what the depth range is in that estuary or that area that we're planting. And we go by that.
Okay. We have another question, and then I will go to our raised hand. But first, from Peter Judge, is there an optimal upland habitat for eelgrass habitat? I imagine that is location specific. I'd love to know what would be optimal for the Great South Bay, which is the closest water body to him.
In the Great South Bay, if you were to look at surveys, the 2018 survey, and then compare it to what's upland of where the eelgrass meadows are, typically eelgrass is found along shorelines that don't have bulkheads. And that's the same in the Peconic estuary. Dr. Brad Peterson's lab had done some work, and they found that the further away eelgrass is from a onshore bulkhead, the more likely it is that the eelgrass meadow is healthy. And we haven't had a lot of experience in Western Great South Bay. Cornell really had been working in Bellport, Moriches, and Shinnecock prior to this year, with a couple exceptions. But this year we're working on a project with SSER where we have 50 locations that we've been out to, and I could say that stands the ground truthing, because most of the sites where we put out equipment for water monitoring that has eelgrass has no bulkheading inshore of it. So I would say for especially for the North Shore of South Shore Estuary, that if you can find a parcel, a shoreline that doesn't have hardened shores, that would be ideal for eelgrass.
Okay. We have a raised hand, Bob Person. I am going to unmute you if you'd like to ask your question. Oop, I think you remuted. Bob, we can't hear you if you're talking. All right. We still can't hear you. So in the interest of time, I'm just going to ask one of these other questions, and then Bob, I'll give you another chance after. Our next question, what parts of Long Island are most of the plantings?
You can take it.
I guess you, sure. It's right now, I mean, this is where all the work that we do is grant-based, pretty much. So currently we're mostly working in Long Island Sound because we have a sound grant, and we're doing some other smaller projects. But yeah, I would say as of right now, the most plantings, current plantings we have going on are in Long Island Sound, because we have several test planting locations going on. And this fall, we're going to be scaling up 2 of those locations. I would say in terms of our history with eelgrass, the Peconic estuary was really where we have tried planting over many, many years. And we've learned a lot in terms of light availability and temperature in the Peconics, and how that relates to, where eelgrass can survive now. So, yeah, I hope that answers your question.
And with the SSER project, over the next 5 years, we'll be doing a lot of work in Great South Bay and the South Shore estuaries. So, we have been doing. We have a current work in Moriches, in Shinnecock and Moriches, and that'll be expanding. That's the focus of that project. So.
Okay. I think that answers our other question that we received. What's the history of the restoration sites in Jamaica Bay and the Western Sound from the map shown in the slideshow? Were they successful, and are there plans for more restoration in here around New York City? So I think you guys.
Well, yeah, neither one of those worked. Well, Jamaica Bay did work, and then Sandy came along. We planted a Breezy Point, and half of Breezy Point wound over the top of our eelgrass restoration. So we'll chalk it up as a win and a loss. However, there is an eelgrass meadow growing in Brooklyn. We do have eelgrass that's been growing for 7 years at Pier 5 in Brooklyn, and there are plans to work with New York City and some other groups, Hudson River Estuary Foundation, to potentially do more work in that area.
And then we have one hand raised. Julia, I'm allowing you to talk if you want to ask your question.
Hi, can you hear me?
Yes.
Oh, okay. That was part test to see if it was everybody or just that guy. All right, anyway. So my question is, I live over near the Smith Point Bridge, near Smith Point by Finn's over there. And over the last few years, there's all sorts of crazy looking seaweed. And I'm wondering if the eelgrass is also being outcompeted. But there's some crazy seaweed near that bridge. I would love to know what all that seaweed is. I don't know if any of you are familiar with it, but.
Yeah, we do work in that area, and we'll actually be working over in that area right off of Smith Point County Park in the next month or so. But so there's there in the South Shore as a whole, there tends to be a lot of seaweed that blooms up. So I couldn't tell you which one you may be talking about because we encounter all sorts that cause big blooms and problems. If it's a hair-like filamentous looking thing, that they're all local species. None of them are invasive or non-native. It's just they take off under certain conditions, whether there's a lot of nutrients in the water. The eelgrass has been coming back in most of the area over there just because you've had the 2 inlets open, which has been really giving nice clean ocean water, which eelgrass prefers. But now that the breach is starting to close, we may see things go back to the way it was pre-Sandy, where there's not as much flushing, and we may see some declines in that area with eelgrass meadows. But yeah, I couldn't tell you exactly about the seaweeds, except that they are natives, and it's a cyclical thing. They'll disappear in another month.
Interesting. Okay. All right. Well, thank you for the info.
You're welcome.
And if you could put in the chat, if observers are allowed for when you're going to be in the Smith Point area. I don't know any way I could help, or if I could just like be around.
We'll be working off a boat, so
Okay. Well,
for that project. But in future projects, we will
Mm-hmm.
be looking for help with the SSCR project over the next 5 years. So we will definitely be putting out feelers for community help.
Okay, awesome. All right, thank you.
I just posted the link for those if you wanted to check out the Marine Meadows workshops. I put that in the chat. And then last, I'm going to give Bob one more time. We're going to see your hand is raised. I am allowing you to talk, and this will be our last question.
Can you hear me?
Yes.
All right. This question kind of pertains to what was just asked by the previous person. You said that a lot of the eelgrass has died off and is dying off, partly because of temperature rise in the water. What is taking its place? I know there are some opportunistic organisms, like you said, algae, the types of things, but what mainly is taking its place? Is it just a vast wasteland, or is there anything else, like an invasive species or anything else that's taking over besides
well, it depends on where you are. So in the South Shore, it just reverts to bare bottom in many cases, because there's not a lot of hard substrate for seaweeds to attach to in place. However, South Shore has a lot of drift species, like the sea lettuce, the big green leafy stuff that forms mats. Now, if you go into peconics, where we lose eelgrass, and in Long Island Sound where we lose eelgrass because they have more energetic wave regimes, you tend to get the fine sediments that the eelgrass accumulates wash out and leave behind the rocks and cobble. So we do get seaweeds moving in. In the peconics, we had one called oyster thief. It's Codium fragile. It's a green, non-native invasive that was introduced on oysters from Japan in 1950s in Orient Harbor. That was a problem back in the day. It's kind of become part of the landscape now. And actually, Stony Brook research found that it, in place of eelgrass, where eelgrass has disappeared, and this seaweed pops up, it actually acts as a good habitat for bay scallops. So not as necessarily as good as eelgrass would be, but it definitely provides a replacement versus bare bottom. And in Long Island Sound, we see a host of different species will take advantage of eelgrass. Most cases, though, eelgrass, as you can see in the picture behind me, that's sugar kelp and some other species coexisting with eelgrass. So in a lot of cases, the seaweeds stick to the hard substrates like rock, and the eelgrass grows in the soft substrates in between the rocks. So and we see that in the peconics as well, with a brown seaweed called sargassum. So
Steve, I was gonna say we might want to mention rapia in the South Shore, just because.
Oh yeah, that's true too. Yeah, good. Thank you. I always forget because it's not something we see a lot of. You want to talk about rupia or?
Yeah, I was just gonna, like Steve had mentioned earlier, we do have this other species. It's not really considered a true seagrass. It's more of a aquatic grass that can tolerate some salt. So it can be found inland in salt ponds and things like that. But we do see rupia kind of pop up in the South Shore as almost like a pioneer species. So, you know, when an area is improving, often you'll see rupia sort of move in first before might come back. So it can be a good indicator species that conditions are improving in an area when you see that.
Another quick question. I'm related. I'm involved with half shells for habitat with the oyster planting and the oyster shell collecting. Do you do any of these eelgrass beds close to any of the oyster plantings as well?
We haven't to date, but we one of the things we're looking at is the Friends of Bellport Bay have a sanctuary area on the North Shore in Bellport. And we're evaluating that site to see if we can incorporate some eelgrass restoration in with their oyster restoration.
Yeah, I was going to say, we have some projects that include both, you know, like the Shinnecock Nation project that we did.
The Tiana Bayside.
Yeah, in Tiana Bayside, they include both an oyster reef and an eelgrass meadow, but they're not exactly right next to each other. They're a little bit, you know, off of each other because the oyster reef is usually a little more inshore in that wave break area.
Thank you.
All right. It is 7:09, so I'm going to conclude tonight, and I'd like to thank all our presenters and our attendees for being here. Oops, sorry, I thought I heard something. Oops. So yeah, I'd like to thank everyone for being here. As a reminder, this webinar was recorded and will be posted to CTUC's website shortly. Lastly, check your inbox to see our follow-up email with resources. And don't forget to check out our future webinars on ospreys and eagles and on small mammals. So thanks all. Have a good night.